All right, so we're good to go. So, last week we had our quiz on adaptations to the environment. So we're going to say goodbye to that. Like I always kind of start class with kind of an interesting moment. Obviously, you guys all know what emperor penguins are, so I'm not really talking about them. But everybody loves penguins in general. And I saw this video, and I'm like, this is adorable. Sometimes you need stuff that's adorable on a Monday. These penguins are at school. It was a news report that CNN had put on about the adult emperor penguin leading these little penguins to school. So they're on parade. They're going to school. It is pretty much the most adorable thing I've seen in quite some time. We could all strive to be baby penguin cute. So now for the next 2 weeks, this is going to be a really short unit because in 2 weeks, or we have this week, we have next week, and then we have spring break already. So this is going to be a short 2-week unit. Next Friday, we'll have a quiz to finish it off because I don't want to have a quiz when we get back because you guys are going to lose it after a week anyway. Got more important stuff going on. So population distribution is what we're talking about today. The retake, I know a lot of people had wanted interest about the retake. So that is available right now. And I will let you use your cheat sheet that you made on the retake. Okay? But all you got to do is let me know when you want to do that, and we can make it happen. Hello, this is Mr. Wells. All right, sounds good. Thank you. Yeah, bye. So retake's ready to go. If you haven't taken the quiz yet, we need to make sure that happens. Okay, so you need to come find me if you didn't take the quiz on Friday. We need to get that done ASAP. Missing assignments, I would make sure we got parent-teacher conferences tomorrow. Make sure that you at least have your labs in because your labs do count as 10 points summative. So if you have those missing, those are really hurting you. If you've got them in, they're helping you quite a bit. And then documentaries. So the Monday of spring break, we will have 2 weeks until we start showing documentaries. So if you guys haven't started thinking about what you're going to do right now, these next 2 weeks are a good time to talk to me about what you think you should do if you're confused. Maybe meet up with whoever you're doing your documentary with to discuss that information. Because 2 weeks from the first Monday of spring break, we're going to be presenting some of these. Okay? So you're going to want to check those schedules, go through the information again, be ready to go. Sound good? Any questions on any of this stuff? All right. There never is any questions, though. So, population distribution. So I've got a couple images here. What is the general trend that you see in this picture? What are the two types we got? Two types of organisms. We got fish, and then looks like I think they're dolphins. What they actually are, maybe tuna. But what are the small fish doing? They're trying to escape by what? Creating a large ball, and then they have what you assume is the predator swimming around the large ball. Okay. What about this one's a little bit of a video, but So looking at the video, what were the three types of population distribution? What did you catch? Aggregated, uniform, and random. Does an organism have to be one all the time? No, they change depending on different types of seasons. So aggregated is the most common on the planet. Lots and lots of animals, plants, clumped together. So we can call it clumped as well, aggregated or clumped. They are grouped together because it is beneficial to them. It's easier to find food. It's easier to find water. Being in a large group with your fish does what for you? What was that? Protection. Being in a large group schooling fish, you make yourself look bigger. I can tell you right now, in that top picture, that's a giant herd of wildebeest, which is very common. You see this a lot with reindeer as well, and caribou in the North America, northern Russia. Do you think a lion is going to go piling into that giant herd? Oh, yeah, Mufasa. It didn't go so well. Herds, flocks, schooling fish, whatever, it is all beneficial to animals, to plants, to be close to each other, because fitness is increased. In Wisconsin, what animals do we have that do aggregated or clump distribution? Cows. Cows are all over the place. They are definitely clumped. Deer, part of the year. During the mating season, deer usually like to spread out because they become very, aggressive or territorial. But the rest of the year, you'll see out in fields, white-tailed deer are clumped in groups of like 20, 30 different individuals. And then you're sitting there in your car as you drive by, like, why do I never see that when I'm deer hunting? But these flock all the time. The benefit to them, say, help find food. Easier if all your females and males are in one space. You don't have to hunt them down. Pheasants kind of do. But if we were to look at an aerial picture of this over a wide area, we'd see groups 10, 15, 20 in group, and then we have a large distance in between. You're not going to have one giant herd of wildebeest next to another giant herd of wildebeest. It just wouldn't work. There'd be a lot of competition there. They really want to spread out. Fish are probably one of the cool, as far as schooling goes, fish use it very, very efficiently, especially smaller fish. I always think of Nemo when I think of schooling fish, the original one. They meet those tuna or whatever, and they make all the different shapes as impressions. I always think of that. Or schooling fish, but that's just me. And then we've got uniform distribution. So all organisms are kind of spread out evenly over a large area. Everything has its own territory. This is very common amongst territorial animals. They like their own space. They have their defined space. And when something invades their space without their permission, they get pretty angry. We all have our bubbles. We like people to stay out of our bubbles. And when someone comes into our bubble when we don't want them to, we get upset. That would be a uniform distribution. I saw an image last night on Twitter. I saved it to my phone with the intent of putting it on here, but I forgot to. But the image shows a harping eagle, which is one of the larger species of eagles that lives in India, Pakistan, Middle East. And over its 23-year life, it continuously traveled from the northern Himalayas down to Saudi Arabia and back hundreds of times. And that was its territory, that was its space. And I'm sure if you were to collar a whole bunch of eagles in that area, they'd all have their own territory that they would follow. We don't have a ton of large predators in Wisconsin anymore, but what are some uniform distributions other than bald eagles that we might see? Well, you can think of it. Organisms might use uniform distribution. Geese would be kind of flocking. Wolves could be more of a, they have a pack. But coyotes don't. Coyotes are usually pretty uniform. They like to be by themselves. They're loners most of the time. They'd be more of a uniform distribution. Raccoons don't like each other either. They'd be a uniform distribution. Gophers, I think, would probably be more of a group of some sort of troop. Possums would be a uniform distribution. They don't hang out together very often. Squirrels could probably be uniform. You don't see squirrels like herding up, or they're definitely not random. Squirrels could be uniform. And then we have random distribution. This is really common in plants. Plants tend to be a random distribution. Wherever they seed, wherever their pollen grains land, that's where they grow. Some plants like to use other types of population distribution, but most of them use random. As far as animals go, the animals that use random distribution are very similar to plants, corals, sponges. Wherever they kind of land up, where the ocean current, where the wind takes them, that's where they grow, that's where they develop. There is no rhyme or reason why they grow where they grow. It's just where they land. It's just convenient for them. It doesn't occur very often. This isn't usually very, very beneficial to most organisms because it usually increases your fitness to either be grouped together or randomly spaced so you can use resources appropriately. With random distribution, you might just land in the wrong spot and you don't have a very good nutrient supply. Just the way it is. There is no rhyme or reason. With coral, it's actually really interesting. Coral spawns once a year. It happens on a full moon in like June. Every coral, male or female, releases giant clouds of sperm and eggs at the exact same time. The wind currents take them away, or not the wind, ocean currents take them away. They develop in a larval stage, and then they kind of plop themselves down where they feel it is closest to them. Random. I watched a lot of documentaries. Don't tell Mr. Wallen that, because he said, I talked to him one time. He's like, I told him I know a lot about history. And he's like, if you say that you watch history documentaries and learn all the information, I'm going to be very upset with you. Because he spent all of his time learning history from books. Google YouTube is very, very handy.
So everyone stand up. Everybody stand up. So now, in this scenario, we are our own population. We're going to be ecology class population. Model me an aggregated or clumped distribution. Clump distribution. It doesn't have to be one clump. You could have a couple clumps. But you guys are now in your herd, or whatever we call humans that are grouped together. An army, maybe? An army of humans? A militia? I don't know. Now I want uniform distribution. This will be interesting. The floor is kind of a grid. Everyone get your territory. Space out. I like Ava's idea, arm width, spinning around. Okay, and now random. You can sit back in your seats for random. Easy stuff. All populations exhibit one of those. A lot of the time, they will switch depending on the type of year. Like I said, during mating seasons, usually individuals kind of like to spread out because everyone gets super territorial. The rest of the year, it's benefit to kind of herd up. Nothing but cute videos today. This one's another one that's cute.
Think about the nature of the rabbit. It lives in fields, so it's a member of the field community or assemblage. Here it has many roles. First, it eats plants, so the rabbit is a herbivore. Some of the plants the rabbit eats might also be eaten by meadow mice. That makes the rabbit a competitor to meadow mice. The rabbit could also have parasites, such as tapeworms. That makes it what is called a host. The rabbit may be hunted by gray foxes. That makes it a source of food for foxes. The fox that eats the rabbit may get the rabbit's parasites. That makes the rabbit what is called a parasite vector. And as a parent, the rabbit may raise over a dozen young a year. So the rabbit reproduces rapidly and is a member of the field community, where it is a plant eater, a competitor to meadow mice, food for foxes, and a parasite carrier. All this helps determine the rabbit's place in the natural world and forms its niche. No two species have niches that are exactly alike. Each species has its own special physical characteristics and way of life that set it apart from all other animals.
We're obviously not going to purchase this video. So, this video hits on one of the most important topics of ecology. It leads to evolution. It makes individuals specialized. It gives different species each their own job. This is the idea of niches, or some people say niches. Don't say niche, please. I don't like the word niche. I like niche. But either way is correct. I've heard a lot of professors say niche. I've heard a lot of professors say niche. It's just the way you want to pronounce it. So you see a vast amount of evolution, different traits, different genealogies, different genotypes that pop up because of different niches. Now I'm saying it. Niches. Birds, you see this a lot. There are thousands and thousands of different bill types, different nesting sites that birds can take. If we look at the beaks of birds, you have toucans, which are designed to pick fruit off of tropical trees. You have woodpeckers, which have really fine, sharp, pointed beaks to drill into trees. Did anyone know that the tongue of the woodpecker actually wraps around the entire skull? It comes around the forehead. It wraps all the way around, and it acts as a cushion, because that woodpecker is continuously drilling into a tree. You know how much force that takes to drill into a tree continuously at high speed? The tongue wraps all the way around the woodpecker's head. You can't see it. It is underneath the skin, underneath the feathers of the woodpecker. It wraps all the way around. It's pretty awesome. It's evolution at its finest. But birds all have different niches. They all have a specific place in the environment where they belong. And nothing else can take that. That is your niche. You guys all have your own niche, your own little space where you live, traits that you use, that you follow, behaviors that you display. That is your niche. It is special to you, and nothing else, no one else can take it from you. When something does try to take your niche, that's where we get competition from. We get competitiveness between species. In any pine tree around here, spruce, pine, cedar, whatever, you can find specific nests for specific birds. They don't nest in the same locations. At the top of the tree, there's a bird that nests there. If you look at this chart, it's called a Cape May warbler. You will only find them nesting in the bottom, or at the very tippy top of the tree. That's its spot. You won't ever find them at the bottom of the tree where you find the, I can't read it, the myrtle warbler. That's its location. If they were to nest in each other's spot, that's competition. There's going to be a fight that takes place. That comes into territory stuff. Every organism has its own niche. Sometimes what's pretty common, and this has happened a couple times throughout evolution of life, you get a bunch of niches that all of a sudden just disappear. The species that filled them go extinct. And what happens right after that, you see mass evolution. Species evolving drastically to fill the role of that missing niche, because it increases their fitness to take that spot. You see this a lot after mass extinctions. The Great Dying was the largest mass extinction that ever occurred. 96% of all living species went extinct. You know what that extinction led to? Dinosaurs. Reptiles before that, not much bigger than slug, were on the earth. They survived the Great Dying. They survived, were able to take advantage of all those free niches, that free space, that free opportunity that was available. And they became the largest land animals to ever live in a couple 100 million years. They were super good at surviving. They existed from 235 million years ago to 65 million years ago. That's a long freaking time. Because they were really good at their niches. They were really good at surviving. They had great fitness. So, give me a species. Give me an organism, an animal. A dog. Anyone got a specific dog? Bulldog. I'm cutting out an order right, I won't see it. So a bulldog. This is our organism. Let's make the bulldog's niche. Where should we start? A house. What's the house for the bulldog? The house is what its habitat, where it lives, where it thrives. A forest, could be a forest. Wild bulldog. What else does the bulldog do? It could be a host. I had a dog growing up, had a whole bunch of heartworms. Host of parasite. Had a whole bunch of heartworms. Dad was feeding him the heartworm pills to get rid of them. Goes to work, comes back. The damn thing got into the parasite pills that he was being given was foaming at the mouth. My dad had to had to go to the store and buy a whole bunch of hydrogen peroxide and dump it down his throat to make it throw it all up. It was real intense. But every individual has its own unique parasite. A bulldog's parasite, you won't very often find a bulldog parasite or a bulldog tapeworm inside a cow. Niches. Those parasites have niches. Their niche is that bulldog. A cow tapeworm, their niche is that cow. There's actually cool evolution that takes place between parasites and other things. What else does the bulldog do? It eats everything. It kills stuff. Kills squirrels, rats, anything that can, it depends on the dog too. Gets whatever it can get its mouth on, it chases, kills. What else can a bulldog do? Mate with other bulldogs. It can mate with other bulldogs. It could, it defecates everywhere. Providing, I don't know if that's how you spell defecate, but I'm not an English teacher, connecting or giving nutrition, food, fertilizer to other organisms. We could keep going. And as we were to add more traits that this bulldog has, we form its niche, its specific location, and no other organism would have that exact same responsibility, that exact same job for the environment. It would be unique to that bulldog. Could be, in this case, it could be unique to that specific bulldog. But everything has its own place in the universe. So now, population distributions, we got herding, we've got random, we've got uniform, we've got niches. All of this connects into populations. If you've got a better niche, if your species has a better niche than somebody else, you're going to survive better. You're going to reproduce more if you have a higher fitness. So we get into these population pyramids. Pyramid or population pyramid that we can talk about. So we have rapid growth, slow growth, negative growth. Rapid growth, what do you see happening in our population pyramid? Lots of young, high population and young age. We have a lot of 0 to 4, 5 to 9, 15 to 19, 10 to 14. We've got a lot of individuals in that population. And then as we go up, they die off. As we get higher, our population gets smaller and smaller. Slow growth, which is a great example of the United States. Right now, our population is sitting right about 300 million people. We're not growing. The number of births we have is about the same as the number of deaths we have. We're holding steady. Negative growth, where the U.S. is actually kind of going towards a negative growth, where you have a lot of old people and you've got very few young people. And this is pretty common right now. The baby boomer generation now is out of the parenting age. They're now 60, 70, 80 years old. We've got a lot of old people. That's one of the reasons our Social Security system is hurting right now. Because you have all these old people that aren't working, and you have very few young people working to actually pay for Social Security for this older generation. So this is a real crisis that we continuously have to deal with. With countries like India, less developed, China kind of shows its population, but China's kind of stabilizing out now. China and India are the largest populations on the planet human-wise. India has like 1.3 billion. I think China has 1.5 billion people. A significant, we have almost 8 billion people now on the planet. So that's a significant percentage of them living in those two countries alone. Third world countries tend to have this type of population where you have a lot of young people. As you get older, your likelihood of surviving is very low. You die in your 30s, 40s just because of healthcare reasons. With those populations, India and China now, a lot of the healthcare is coming now. So those individuals that would typically die in the 30s, 40s because of a disease are now living into their older age, increasing that population size very quickly. So this kind of plays into population density. Number of organisms within an area. As an individual size of an organism gets bigger, usually you see the population density decrease. So if you have in the spring, you have a bunch of fawns, whitetails, new boars, new birds, you've got a lot of population density increase because there's a lot of new individuals in the population. As those individuals grow and get bigger, you lose some individuals, they die, some individuals immigrate off, they go somewhere else, you have some individuals move in. But typically, as a species grows in size, you get fewer and fewer individuals in an area because there's a lot more competition there. When we draw these populations, we can draw it as, I don't remember what the video talked about, we can draw it as a J curve, and we can draw it as an S curve. J curves are not what you want in your population. You have extreme population growth, growing really fast, not a lot controlling you. You don't have anything competing with you. Eventually, you're going to hit a line called the carrying capacity. That is how many individuals that your ecosystem can hold. Top. Can't hold any more, can't hold any less. But what happens is you keep going past that line a little bit. You keep growing exponentially, you have more individuals than you can hold. Eventually, you're going to hit a hard line where everyone's going to die off. Your population is going to crash because there's not enough resources there. Not enough food, not enough water, not enough space. Your population is going to crash, and it's going to dip way down. On an S curve, this is a J curve here, but on an S curve, you're going to see a more transitional, slow population growth. And at the very top of your population, you're going to hit your carrying capacity, and you're just going to level off. Having an S-curve population is pretty rare. Not a lot of species actually have that perfect S-curve where they hit the population or the carrying capacity and they sit there. Doesn't happen. You have a whole bunch of other stuff in the environment that you just can't predict. You have different seasons. You have drought that can happen, floods, tornadoes, maybe a bunch of new predators are born in. Just depends. We see a lot of these J curves in the Canadian lakes and the snowshoe hare in Canada. The green line represents the snowshoe hare, the red line represents the lakes in that bottom right graph there. What do you think is going to happen, or what do you notice happening when the lynx population gets to its highest points? What do you see happening in the hare population? It dips. So traditionally what happens, the hare population, the snowshoe hare population, is always just a little bit ahead of the lynx. As the snowshoe hare population increases, you got a bunch of mating going on, a bunch of breeding, a bunch of new individuals, you got high resources, population goes up. The lynx now have a giant food source they can take advantage of, their population goes up. More lynx equals less hares. Population of the hare dies. Now you have a whole bunch of lynx and not a lot of food. What happens to the lynx? If there's not a lot of resources, not a lot of food, what's going to happen to your lynx species? It's going to starve. You're going to have a lot of individuals dying because they just can't find food. There aren't enough snowshoe hares to support your lynx population. So dispersal, whole bunch, this will be the last slide of the day, whole bunch of different types of dispersal. How organisms spread out. One of the biggest issues that environments face, ecosystems face, is inbreeding. If you don't have a good dispersal technique, you're going to have a lot of inbreeding going on in your population. And it's going to have a negative effect on your genetics. You're going to start to see a lot of mutations you don't want to have. Dispersal allows organisms to spread out. How do you see maple trees trying to disperse their seeds? They have helicopters. They have those helicopter seeds. They drop them all about the same time. Usually it's in late summer when we have a lot of wind. That wind picks up those helicopters, spreads them all over the place. Gets them as far away from their parent individual as they possibly can. So they don't have inbreeding. So you get genetic diversity. Fish use ocean currents a lot. Here we have the salmon. Salmon, they spawn, they lay their eggs, they give off their sperm, they die. Their entire life is spent reproducing. That's what they're built to do. Pass on their genetics and die. Because they use so much energy trying to get to where their offspring can survive. So there we have two salmon spawning, male releasing sperm, female releasing eggs. They fertilize, get carried downstream towards the ocean. Spreads out. But really important to keep populations genetically diverse. If you don't have good dispersal, your genetics are going to get pretty similar. You're not going to change much. You want to have the dispersal stuff going on. All right, that's all I have for you today. If you haven't taken that quiz yet, you need to come talk to me so we can get that figured out. Retakes are ready to go if you want to do a retake.